All right, we are back with some practice on solving systems of equations using the equal values method. Now, we've already talked about how we can use the graphing method, but sometimes it's not the most accurate, especially if it's not a whole number. So, we are going to focus right now on how we can use the equal values method. And it is perfect when you have equations like this that are in slope-intercept form. So I'm going to start by comparing and finding the system where these two equations, the red and the blue, are the same. Now, notice that 2x plus 7 is equal to y, and negative 3x plus 12 is also equal to y. And remember, a system of equations is where we're trying to find when those two equations, those two relationships, have a value that is exactly the same. So if we are assuming that y is the same, we can take those two equations and set them equal to each other. So again, because they are both equal to y, we can assume that these two are equal to each other and take away those y's and just set those equal to each other. So 2x plus 7 equals negative 3x plus 12. Now, I am going to solve this like I would any normal equation for x. So my goal is to get those x's by themselves on one side, so I'm going to start by adding 3x to both sides so that I can get rid of those negative x's. This makes 0. And I'm left with 5x plus 7 on the left side and 12 on the right. Now I want to get rid of that 7. I want to get those x's by themselves. So I'm going to take away 7 from both sides. And I have 5x equals 5. So 5 times what equals 5? I'm going to divide both sides by 5 and get x equals 1. Now, I have figured out that these two equations have the same value when x is equal to 1. In order to find out and test that this is correct, we now need to look at both of these equations and figure out what the y value is when x is 1. So I'm going to move this up here. All right, and now I'm going to test out the red equation first. I'm trying to find the y value. So I have y equals 2 times x, which is 1. So 2 times 1 plus 7. 2 times 1 is 2. 2 plus 7 is 9. So y equals 9. Now, if we've solved this equation, the system of equations correctly, I should be able to do this blue equation and get 9 as well. So I'm going to try that. Y equals negative 3 times 1 plus 12. And again, just solving for y here. So negative 3 times 1 is negative 3. And then negative 3 plus 12 is 9. So these two equations are exactly the same when x is 1. I just wrote x. When x is 1 and y is 9. That is the solution. And we write the solution as a coordinate point. All right, that was our red and our blue equations. Now we can do the same thing and we can test out. Let's do blue and green this time. So again, I'm assuming that y is the same. So I'm going to take those two equations. This one is our blue and green. I'm going to take those two equations. The blue one is negative 3x plus 12 and the green one is negative 1x minus 4. So again, I'm solving for x first. I am going to add 3x to both sides. That way my x's will end up positive. So I have negative 1 plus 3x is positive 2x. And on the left side, I'm just left with positive 12. That made a 0 pair. All right, and now I want to get 2x alone, so I'm going to add 4 to both sides. I'm left with 16 is equal to 2x. I'm going to divide both sides by 2, and I get x equals 8. So, assuming that these two equations are equal, we're then going to go back and test these. Find that value of x. So my blue one, the equation is y equals negative 3 times x, and x is 8, plus 12. And negative 3 times 8 is negative 24. Negative 24 plus 12 is negative 12. So y equals negative 12. Now, if I want to check to make sure I've solved correctly, I'm going to do the same thing for green. The equation is y equals negative 1 times x, which is 8, minus 4. Finding that value for y that makes this true. Negative 1 times 8 is negative 8. Negative 8 minus 4 is negative 12. So y equals negative 12. So we did get the same thing. We got negative 12 and negative 12. So in this set of equations, the x value that they are both the same at is 8, and the y value is negative 12. All right, now the last one that we have to test is our red versus green. So we are going to do that one. We're just going to really quick write down those two equations. The red one is y equals 2x plus 7. And the green one is y equals negative 1x minus 4. So now we're testing, this is red and green. When are those two equations the same? Starting by solving for x. And I'm going to start by adding 1x to both sides. I get 3x plus 7. This was 0, so equals negative 4. I want to get x alone, so I'm going to take away 7 from both sides. This makes a 0 pair. I'm left with 3x. And then negative 4 minus 7 equals negative 11. Okay, so this is where it gets a little bit weird. So notice, if we divide both sides by 3, we are left with, and I can turn this into a decimal, I can turn this into a mixed number, I can leave it as an improper fraction. I'm going to leave it as an improper fraction, I think. This negative 11 thirds. This is technically equal to, let's see, 3 times 3 is 9, so 2/3 left over. It's the same as negative 3 and 2/3. So if you're more comfortable with mixed numbers than improper fractions, that's fine. So our x value is not actually a whole number. And we actually found that when we were doing this on our graph, and we kind of made a prediction. Maybe it was around negative 3.5. Well, 2/3 is pretty close, but it was hard to tell with the graph. So this is much more accurate, especially when we're talking about values that aren't whole numbers. It is harder to tell on a graph. especially if you have a scale that is a little bit bigger. All right, so now we're going to test those out. And we have, let's test the red one first. We have y equals 2 times negative 11 thirds. Again, I would prefer to use the improper fraction here and then simplify after. Plus 7. Okay, so 2 times negative 11 thirds. Remember, when we multiply fractions, we're multiplying across. 2 times 11, negative 11 is negative 22. 1 times 3 is 3. I'm now going to change that into an improper fraction. 3 goes into negative 22 7 times with 1/3 left over. And it's a negative and then plus 7. So negative 7 1/3 plus 7 is equal to negative 1/3. So that's our y value. And if we scroll up again to that graph that we talked about last time, we guessed that it was probably somewhere around negative 0.5, which is just a little bit bigger than the actual answer, which would be like negative 0.3 repeating. So we are pretty close with our graph. Not exactly accurate, but that works. Let's just finish this off, double check that we get the same thing with the green equation. That equation is negative, y equals negative 1 times negative 11 thirds minus 4. Now, negative 1 times negative 11 thirds really is just going to turn that positive. So this is actually positive 11 thirds minus 4. Remember, we said that's the same as 3 2/3. So 3 2/3 minus 4, y equals negative 1/3 again. So we did get that same answer. Our solution to this system is the x value was negative 3 2/3. The y value is negative 1/3. And those are the solutions. That is how you use the equal values method to solve systems of equations. Hope it helps.